We want to solve this differential equation. And so if you look on the left-hand side, you notice that y and x can be written as a product, and they're separate from each other. In other words, they're just a product. Likewise, on the left. So what we can do is divide both sides and get all of the terms with x's on one side and all the terms with y on the other. So I'm going to divide this side by x plus 1. I'm going to divide this side by y squared plus 1 to both sides. Okay. In doing so, you'll want to note that this term right here cannot equal 0 for all real values of y. However, uh, if x is equal to -1, this is equal to 0. So in doing this step, we're going to say that x can't equal -1. So that way don't divide by 0. Okay. Otherwise, we're going to go ahead and write this out. I have y dy, these two terms here, divided by this term over here, which is y squared plus 1. And that's going to be equal to then moving x and dx over here, and then dividing by this x plus 1. Okay, so we end up with this result. Now you may notice that this part right here is actually, it looked like it might be a trig sub, but because of the extra y up here and the y squared in the denominator, this is just going to be a simple u sub. And this one here, you could do a u sub on it. Given our current work, I think it might be more natural to divide this out. So if we have x plus 1 going into x, okay, you would see is that will go in one time. You get an x plus 1 that we're subtracting. And so you get that this whole thing is going to equal 1 plus 1 over 1 plus x. Okay. That should be a -1 from the fact that we're subtracting here. So this becomes the x's cancel and you're left with a -1 down here. Okay. All right. So let's go back and rewrite this. And we'll put these in the integral. So we have the integral of y dy over y squared plus 1 is equal to the integral of 1 minus 1 over 1 plus x. This is dx. Okay. All right. So here we're going to make a u sub. So we're going to let u equal y squared plus 1. So du is going to equal to y dy, which is exactly what we have on top here. I just need to divide both sides by 2. And that will then give us a 1/2 the integral of du over u. And likewise over here, I'm going to make a u sub of 1 plus x. So du is going to equal dx. This is equal to the integral of dx minus distributing that dx in minus the integral of du over u. Okay. All right. I probably should have chose a different letter than u. Keeping those two separate. These are not the same. So this is 1/2 natural log of u in absolute values. And I can drop the absolute values here because y squared plus 1 is y squared is positive and we're adding 1 to it. So this is always going to be positive, but just for the sake of completeness, this is going to be x here minus the natural log absolute value of u, call it like u tilde or something. Just kind of indicate that it's a different u. Plus some constant of integration. And then, what do we have here? Let's see. I can bring that exponent up and substitute this in. So I get that this is the natural log of the square root of y squared plus 1. Okay. So it'll be this first term is equal to x minus the natural log of what's the value of 1 plus x plus a constant. Okay. All right. So there's a little bit more algebraic manipulations we can do, but for the purposes of this problem, it is solved. Yeah, I hope that was helpful, and I'll see you in the next video.